We can't. All right, here we go. Yesterday, repeat today. Different worksheets. What's your test?
Science.
When is your science class? All right. Somebody tell me when there's 10 minutes left. We'll take the last 10 minutes study science.
Let's go.
What's your test on? What clouds form thunderstorms?
Are you ready?
What clouds form a layer?
Stratus. No, you need to go.
What is the scale for tornadoes? What is the scale for hurricanes? Blah blah blah.
Saffir-Simpson.
Saffir-Simpson. Right.
I said safer.
What is stronger, Cat 1 or Cat 5?
Cat 1.
Wow.
We have Cat 1 in Colorado, by the way. We don't have hurricanes, but we will get 70-mile-an-hour winds in Colorado. So technically, we have hurricane force winds in Colorado. Yeah.
I have a question. I have a question.
Didn't know that. I'm not the science teacher, so make sure your facts from your science teacher. Thank you. Let me give you one of these. Okay.
I know, but we also have to do it on air pressure, humidity.
Air pressure is measured in.
Thermometer.
How is air pressure this might be a question test, but how's air pressure measured?
High and low.
What?
High and barometer.
Measure with a barometer.
We said measure.
Did she ever show you a picture of an early? My science teacher in 8th grade, back when, well, we knew that mercury was bad for you, but literally, I remember her taking a jug of mercury and like saying, "Here you go, kids, hold your hands out. You want mercury?" And we were like, "Yeah."
What's mercury?
And so she poured mercury into our hands, and we were like, "Oh, it's fun to play
Wait,
with."
are you serious?
I'm 100%
She's
serious.
stupid.
Right?
Why didn't you just buy it?
Well, my mom had told me that mercury was bad, so we knew it was bad, but we were like, "Hey, the science teacher said," she literally, I'm not joking, she poured mercury in her hands and let us play with it a little bit.
Did anybody drink it?
No.
Was there any side effects?
No.
Mr. Chartier.
Someone died.
All right. So she took it to Malachi. Put that away. Go back to your seats. We're not going to all by ourselves. And no, I'm not going to say yes this time. You need to start bringing pencils to class.
I do. They always get stolen.
So a barometer is made by you take a test tube, except a very long one. You know what a test tube is, right? You fill it full of mercury to the very top. And then what happens is you take a bowl and you put the bowl over the top of the test tube. You invert it like this and then pull up the test tube slightly. So some of the mercury, so the tube is like this, right? And so the mercury is about right there. And what happens is the mercury will come down to a certain level because of gravity, right? But what happens is air pressure pushes down on the surface of the mercury and keeps the mercury on the test tube to a certain level. And then there's a measurement along this. So that's why it's literally called, you may hear it on the news, there's 33 inches of mercury. What do they literally mean? That on the test tube, the mercury goes up 33 inches.
What is mercury though?
Mercury is a metal.
Yeah, how it's a liquid
It's
metal.
and its symbol is anybody? Mercury. It's not Mi.
It's like
It's not even a letter even remotely close to mercury. It's Hg. Is mercury. Is Latin for, I don't know.
Hungary.
We can look it up later. All right. So that was two random bits of facts. Now let's get back to math. All right, divisibility rules. We did this way back when. Divisibility rules. All right, Ben, what's the divisibility rule for 2? How do you know that a number is divisible by 2?
It's even.
If the first or last number.
No.
If the first or last number. Okay, last number means the number is far to the right. Doesn't matter what the first number is, matters the farthest number to the right. The farthest number to the right, as long as it's the whole number, or integer, I should say now that you know about negative numbers. If that is an even number, then it's divisible by 2. All right, Malachi, what's the divisibility rule for 3? In other words, is I don't know, is 45 divisible by 3? What's the divisibility rule for 3? Divisible rule for 2, last number, if it's even, then it's divisible by 2. What's the divisibility rule for 3s? 47 is odd, and 3 doesn't go into 47. Divisible rule for 3.
Oh, I know.
Like add the two numbers.
You take the numbers of the digits of the number and you add them. 4 plus 5 is 9 divisible by 3. 45 is divisible by 3. Give me a 4-digit number.
563.
4-digit number.
5,000.
Keep talking.
687.
Is that number divisible by 3? Let's see. 5 plus 6 plus 8 plus 7.
26.
Does 3 go into 26?
No.
Not divisible by 3. That's the rule for 3. Divisibility rule for 4s. Who's got it? Is this number, I'll make this 8. Is this number divisible by 4?
Yes.
How do you know?
Because they have 8.
Is this number divisible by 4?
No.
How do you know?
Because we're smart.
No. You've forgotten the divisibility rule for 4s.
It is
Anybody
divisible.
remember?
It is divisible.
I know, but does anybody remember the rule?
No.
It has a 4 in it.
No, absolutely not.
You add it to multitude.
16 doesn't have a 4 in it, and it's divisible by 4. What's the divisible rule for 4s?
If it's an even, if the last number is an even.
No, 26 is even, it's not divisible by
If
4.
the last two numbers.
Last two, thank you, Ace. One person. You look at the last 2 digits. And if those digits, 72, are divisible by 4, then it is. You're like, well, that's still a lot of work. Agreed. 4s are not the fun ones, right? It takes a little bit of work. Sometimes you're lucky if
It's 18.
if it's 18, obviously no, but
No, I'm saying that divided
Yeah,
by
right.
18.
right. So all you ask yourself is 72 divisible by 4? And then the answer is yes. Okay. Divisibility rule for 5s.
Oh, it's just if it ends with a 5 or a 0.
Ends in a 5 or a 0, guaranteed. 6 is a hard one to remember.
2 and 3.
Oh, one person, Abby, remembers. If the number is divisible by 2 and 3, not 2 or 2 and 3. So the divisibility rule by 3, you got to have all the digits. Divisible rule by 2, it's got to be an even number. Okay, so that's 6. We don't have one. Well, there is one for 7. Didn't teach it to you. 8 is like 4, except you look at the 5,652. You look at the last 3 digits. The 8s are no fun. That's also why I didn't give you that one. 9 is the same rule for 3, except you ask yourself, are the digits divisible by? Okay, so let's see if this one's divisible by 9. 5 plus 6.
Excuse me,
Yes? Yes, ma'am.
can I have Gavin for just a minute?
He's on his way.
Thank you.
She?
I said he.
No, you said she.
I may have slurred, but I said he.
You
All right.
said she.
I said he. It may have come out as that, but I said he. 5 plus 6. Plus 5. Plus 2. Is 18 divisible by 9?
No.
Yes.
So 5,652 is divisible by 9. And the last one we had was 10. Divisible rule for by 10s. All right. So those are your divisibility rules. That's questions what? 1 through 6. All right. Next section. Next section. All right, square roots. Going way back to box 1. Remember box 1. What is 1 squared? 1 squared.
1,
What is 2 squared?
4,
3 squared.
9,
4 squared.
16,
5 squared.
20,
25. 6 squared.
30,
7 squared.
49,
so forth and so on. This column right here are called perfect squares. When you take the square root of a perfect square, you simply ask yourself, what number times itself is this number? What number times itself is 25?
5.
So the square root of 25 is 5. Lily, what number times itself is 100? 50 times 50 is not 100. 10 times 10 is 100. Therefore, what's the square root of 100?
10.
You got it. Those are all, at least in 7th grade, those are all perfect squares that you will get questions to. Sure, go for it. Questions on square roots? Okay. Oh, well, let me point this out just in case it ever happens. What is the square root of -9?
Oh, -3.
Is there a number times itself that is -9?
Oh, wait, no, there isn't.
There isn't. So when a negative is on the inside of a square root, guess what the answer is always?
Positive.
Give me a number times itself that's -9.
-3 times 3.
That's not times itself, that's times a different number. 3 and -3 are not the same number.
-9 times 1.
Those are not the same number. 9 and 1 are not the same number. It's got to be like this, 10 times 10. Same number times same number. So what number times itself is -9?
Not 3.
-3 times -3 is +9, not -9. So-
There is no number.
Yeah, but those aren't the same numbers. There isn't, so what's the answer to this?
0.
0 is a number.
No.
-0.
A
X.
question mark.
This symbol right here, which means no solution. Okay?
It also means.
No, that means in math, it means no solution. Okay? That means there is not an answer to this question until you get to high school. Okay?
What's the answer in high school?
Why do you ask?
3i.
And I stands for
I don't know.
imaginary number. And no, I'm not lying to you. All right.
Wait, can I tell you something?
No, we're staying on this.
Here's I.
We're staying on this. All right, square roots, easy ones. Next section starts with number. What number?
12. 13.
Okay,
No.
all right, here we go. The most missed question, however, the most understood question by 7th and 8th graders. You get these 3 letters, LCM and GCF, and we'll spend a chapter on both. Kids will get it, as long as it's written on a resource card, and then whoosh, they flush it from their brains and they forget it for an entire year until we get it again. LCM and GCF, hard to remember. There's 2 of these, LCM and GCF. LCM, who remembers what it says?
Least common multiple.
Least common multiple, which would lead you to believe that least means it's a small number. It's the opposite of that. It turns out, and this is what caused me problems in 7th and 8th grade, I would see the LCM and I would say least, and I would think it was the smallest number. It's the smallest multiple that both numbers go into. So this number ends up being bigger, potentially, than both of these. The GCF is greatest common factor. It is the largest number that goes into both of those numbers. So what is the biggest number that both of these go into, or smallest number that both of these go into? 8. 16 is a multiple, but not the least common multiple. What is the greatest common factor?
72.
That goes, greatest common factor is the biggest number that goes into both of those numbers. 4. Okay, so 8 is the LCM, 4 is the GCF. Easily forgettable. Remember when I taught this, there are 2 techniques. There's the book technique, and then there's what everyone else uses. The book technique, in every single math book you open up, wants you to do a factor tree and then apply these weird rules that no one remembers. To find the least common multiples, you write the multiples of each number. 8, 16, 24, 32, write a couple of them. 4, 8, oh, we can stop at 8 because we have the same numbers. For greatest common factor, we list every single factor that goes into that. All the factors that go into 8 are 1, 2, 4, and 8. The factors that go into 4 are 1, 2, and 4. We pick the largest number that goes into both. This is how human beings do this. Mathematicians, we all think that everyone will remember the other method, the factor tree, and nobody remembers that. Okay. Remember that was the one where you got two numbers times itself. You circle the prime numbers. Everyone forgets how to do that.
Oh, yeah.
No one will forget how to write out multiples or factors. All right, LCM and GCF take us to question number 25?
17.
Let both.
Oh, wait, no, 17 is.
25. No, 21.
Yeah, 21.
Okay, turning decimals into fractions. Who remembers the rules or the steps, I should say? Remember?
Wait, no.
How do we turn it into a fraction?
I remember.
Oh, you moved it to the left twice.
That doesn't make a fraction.
Wait, no. No, what am I
That's,
talking
you're
about?
thinking of turning to a percent.
Yes.
So.
No, I didn't.
What?
Then first you find out if it's 100, 10, or
Before you do that, what do?
you put it
I just, go ahead.
right over 100.
I just look at the number. What's the number? Why are you two getting up? Move back.
I was in on your
Jaden. Don't do that without asking permission. Come on. Step number one, you look at the number. What's the number here? What literally is the number?
0.00.
So there's only one number there, and that's without the zeros.
Oh,
5.
5. So 5 goes on the numerator. What goes in the denominator? We look at what place value the last digit is in. What place value is that 5 in? And you put 1,000. It was in the 10th place, you put a 10. It was in the 100th place, you put 100. And then we simplify the fraction, reduce it. 5 goes into both, so we get 1 over what? 200. Okay, and you're done. We better do a different one because you guys have forgotten how to do this. Pick one.
16.
That's in this section. 24?
21.
Looking at the number.
24. Oh, I see what you're saying. Okay, 24. Hey, what's that number there?
0.6.
Yeah, but what's the number?
16.
So 16 goes on the top. What goes on the bottom?
100.
You put 100 and now we reduce. What goes into both? 4. 4 goes into 16. 4 goes into 100.
25.
And you're done. It's that easy. Now, if they put a whole number, somebody give me a number.
24.
13.
6.013. How do you do that? Well, whatever this number is goes out front because it's going to turn to a mixed number. What's the number that I put on the top of the fraction? 3 is in the what place?
1,000.
Can that be reduced? No, and you're done. That's how it's done.
Here.
Yes, since you're in 7th grade now, they can make it negative. What would change?
You'd put a negative.
You put a negative and you're done. Bam.
So I can't see what you're writing.
I know you can. All right. All right, next section.
25.
25. All right. No one's friend. Hey, hand sanitizer over there. How do you change a fraction to a decimal? Go. How do you change a fraction to a decimal?
So what you do is you see what's on the bottom, like if it was, so if it was like
Easy way. How do you do it? Every test, every quiz I hand you back, this is on the top of your paper. And I say, change it to a percent. Before you do that, you change it to a decimal. What do? I grab my calculator, I type it in. What do you type in?
7 by 10.
Talk.
7 divided by 10.
So guess what you do to change a fraction to a decimal? Think about what you just said.
You do 7 divided by 10.
So you divide what by what?
7 by 10.
In more general case,
Top by bottom.
top divided by bottom. Okay,
And negative.
go. Top divided by bottom. Fun, not fun, what?
Not bad.
Not bad, okay. Most kids would say this is not too much fun without a calculator, but unfortunately you got to do it. Top divided by bottom, top divided by bottom. Is everybody with me? Some of you look like you're completely, totally dead. You're not paying any attention. All right.
Can't you just move the decimal over one?
What do you mean move the decimal over one?
It's a 10, so
When it's a 10 or 100, absolutely. But how many times is that going to happen?
not very
So I usually don't even acknowledge that unless someone brings it up, because it'll give people the false impression that it can always work. And it only works if it's a 10 or 100 or 1,000, but absolutely positively. So if it's 10,000, how many decimal places? If it's 10,000, it would be 4 decimal places. Okay. All right. Adding, subtracting. Bo, we are allowed to add and subtract fractions as long as, complete the sentence. As long as we are allowed to add fractions as long as. Can we add these two?
No.
Why not? So we are allowed to add or subtract fractions as long as, Bo. There you go. Do we have same common denominators? Scratch work off to the side. 6 over 7, 1 over 5. Hey, now we're going to use, and this is why previously they teach you LCM. This is why we go to, why all teachers, 6, 7, 8, 5, 6, 7, 8, all teach LCM, GCF, because you're going to use LCM, find common denominators. Most kids don't even realize they're doing LCM. All right, what's LCM of 7 and 5? Leaves common multiple. What's the smallest number that both 7 and 5 go into? 35. So I write a 35 fraction bar. 35. This is all scratch work. What times 7 is 35?
5.
Do we multiply the top, the bottom, or both by 5? Both by 5. So top and bottom by 5. What you're really multiplying by is 5 over 5, which is 1. So you're really not changing the fraction. 6 times 5 is 30. What times 5 is 35? So times 7 over 7, which is really just 1. 1 times 1/5 is 1/5. It didn't change anything. The numbers visually change. The value doesn't. 1 times 7 is 7. So here are my two fractions that we add together. 30 and 7. So we get 37 over 35. Make sure you read the question carefully. If they say write as a mixed number, make a mixed number. If they don't, well, that's a perfectly fine answer as long as it's fully reduced. Hey, when you reduce, guess what you're actually reducing by? If you were to reduce a fraction, guess what you're reducing by? For instance, 10 over 15, I would reduce that. Guess what you actually reduce by? The GCF. The largest number that goes into 10 and 15. That's why they have you do GCF, because you use it, LCM, GCF, for fractions. Now,
So say it doesn't like make a mixed number and we do, is that fine?
that's fine, but it has to be reduced, right? If it was 1 over 35, perfectly fine answer, okay? As you move into 8th grade, weird things can happen. For instance, you are always used of when, I'll do a nice, easy, friendly one, right? You are always used of 4/5 minus 1/5, right? Nice, easy, friendly one. What's the answer? Okay, guess what happens from now on?
Big long numbers.
What did we, literally the chapter we're in, guess what happens? What you learn about.
Oh, come on.
So now they can write 1/5 minus 4/5. A year ago, your head would explode because you wouldn't know what, you can't do that. You only have 1/5, you can't take 4/5 away from it, and now you learn you actually can do it. Hey, the rules don't change. It's still, hey, common denominators, you rewrite the denominator. 1 minus 4 is, same or different signs. So subtract, big minus small gives you, big minus small gives you more negatives, more positives. So we get -3/5. Okay, there you can, that could happen because now you know negative numbers. Wouldn't have happened up to now, but now it can.
Is it, so it will happen this year?
It can happen, right? From now on. Now you know negative numbers.
Do you have any super glue?
All right. Next section is what? Multiply?
Yeah, with negative.
Multiply. And once again, since we know negatives now, we can do, oh, we got to do improper fractions. All right, mixed numbers. Are you allowed to add, subtract, multiply, and divide with mixed numbers?
Yeah. 100%.
Not multiply or divide ever. Adding, subtracting, if you've got common denominators, absolutely go for it. If you don't, remember my recommendation is to always just change it to an improper fraction, make your life easier. All right, some of you, that's usually just the smart kids will figure out maybe there's an easier way, go for it. But you cannot ever, no matter what, you cannot ever multiply or divide with mixed numbers. Adding, subtracting, it's kind of up to you. I don't teach, hey, if it's a mixed number, leave it as mixed. I just say change it to improper fraction. That way you're always in the custom of changing mixed numbers into proper fraction. All right, the big circle, how do we make a mixed number into an improper fraction? What do we do? Somebody, what do we do?
Oh,
You.
you multiply.
Start with the bottom,
Yep,
2 times the number out front, the whole number,
yep.
and then
Add to the.
add the numerator all over
Uh,
the denominator. So we get what, 5 over 2? So we get 5 over 2 plus 1/7. Common denominator is 14. What times 2 is 14?
7,
So top and bottom by 7, which gives us
35 over 14.
35 over 14 plus
2 over 14.
2 over 14, which gives me
37.
37 over 14. To go the other way, to turn an improper fraction to a mixed number, you ask yourself, how many times does 14 go into 37?
2.
Well, this is a bit harder. 2 times 14 is 28. We're kind of thinking about that in our head. 37 minus 28,
9.
14.
other way around. There we go. Okay. All right, let's go on to multiplication. Multiplication. All right, what number is multiplication?
51.
33. Thank you for the person who said 15. All right, 33. Notice now that we have negative numbers, they're going to throw negative numbers in there. All right, what are the rules for multiplying with fractions? What are the rules?
Oh, cross multiply?
No. Cross multiply is proportion. When one fraction equals, we'll do that. It's the last thing we do. What's the rule for multiplying with fractions? Come on, you guys. Somebody remembers this.
Abby.
What do you got?
Cross multiply.
No, that's for proportions. What do you got? That's division. Multiply with fractions. What's the rules? Not a single person in here has got this. What do you got, Ben? I think you might be saying it right. That's not the way I said it.
Do like a 3 times 7.
Okay, so how did I describe that? And I think you're right. I think Ben's right as well too. You're just not describing it well.
Well, you multiply. You multiply. So on this one, you multiply. On 33, you'll do 3 to 7.
Okay, how did I describe that? From yes, you have it, and a bunch of you do. We just multiply straight across, not cross multiply x, but straight across. Tops with tops, bottoms with bottoms. Hey, where does this negative go? What's a negative times a positive?
Negative.
So the answer you can already put equals negative and then a fraction bar. I know it's going to be negative. And now we do tops with tops, bottoms with bottoms. What do we get? 21 over 10, and the whole thing's negative. Can that be reduced?
No.
I don't know if the answer in the back writes it as a mixed number, but you can handle it from there. Okay? 10 goes into 21 2 times with 1 left over. So negative 2 1/10 as a mixed number. Yes?
Yes.
Are you going to remember that? Because, boy, that took a lot of prodding and whipping to get you there.
I'm not.
All right.
I didn't even realize what you did.
All right, 35. What's the problem here?
It's big.
Problem here is that it's
Mixed number.
mixed numbers. So what do we got to do?
Add them together.
Absolutely
I
not.
mean, not add them, but make them.
Multiply, add them to the numerator. All
Anytime
over the
Make them into improper fractions.
Exactly. That's
Hey,
what I said.
what's a positive times a negative?
Negative.
A
So we
negative.
put negative as the answer over here. But we do have to change those to improper fractions first. All right, first one would turn into 3 times 2,
8 over 2.
6 plus 2 is 8. So we get 8 over 3 times
39 over 10.
negative 39 over 10. See what I did? All right, we're not going to do that multiplication. Those are some ugly numbers. We will briefly, though, since you brought it up, talk about cross, not multiplication, cross reduction. Hey, do you want to multiply 8 times 39?
Yeah.
I don't. 3 and 39. Can you reduce?
Yeah.
3 goes into 3.
1,
3 goes into 39.
14,
13 times. What goes into 8 and 10?
2,
2 goes into 8.
4 times,
2 goes into 10.
5 times.
So this is 4 times 13, 1 times 5, much easier math. Okay. All right. What happens with division?
Copy, not flip.
Why is that more memorable than multiplication?
Because copy, dot, flip.
Right. It does. It does. So division, we do a copy, dot, flip. We copy the first fraction. Dot means multiplication. We flip the second fraction, multiply, or cross reduce if you can. 2 goes into 2.
Once.
2 goes into 4.
We don't need a cross case, this one.
Okay. Multiply straight across and you get
1 over 4.
1 over 4. Okay. Copy, dot, flip. I promised you the last 10 minutes, so I'm trying to go quick here. Let's see. Next thing. Thank you for staying with me. We have some 2-step equations. Oh no, we have proportions. Yeah, let's do proportions. And we'll call it quits on proportions. You can do the 2 steps by yourself. How do we, since who wants to describe how we do this? Go for it.
So first we need to look where our,
Notice we have 2 fractions equal to each other. Go.
we need to figure out where our unknowns are.
Okay, our unknown is in the second fraction in the bottom.
And then we need to look how it's connected to the 4 and it's connected by division.
You're making it way too She's trying to solve it using algebra. Could you do that? Yes, you can. But if it's 2 fractions separated by an equal sign, cross multiplication, it still is algebra. It's based upon algebra. It's a little bit. What you're trying to do right there is, we could do that. That would actually take a couple more steps. How about we just use cross multiplication? Cross multiplication, remember, butterfly method, whatever you want to call it, can only apply if it's 2 fractions separated with an equal sign. It is algebra. We could do it exactly the way she's describing it. It would just take a couple extra steps. Let's just use cross multiplication. So Caden, cross multiply. What do we get?
So we did 12 and then 8n.
12 equals
8n.
8n. Where's the variable?
It's on the right side.
What's attached to it?
8
How's it attached?
multiplication.
So what are we going to do to both sides? 5. 8 divided by 8.
Cancels out.
So we're left with n is equal to 12 over 8, which would reduce to
1 and so
what goes into both? 4. 4 goes into 12,
3 times
and 4 goes into 8.
twice.
3 over 2. We're done. Yeah. Yeah, you still have to include the negative, so we'll do that one next.
Mr. Sugar, so you're saying 4 over 3 halves?
It would make more sense here if you change that to a decimal, 1.5.
Well, yes.
But 3 over 2 is actually the answer, but hold on a second, we'll get to it. All right, what number is that?
That was 41.
No, 39. 39?
Yeah.
I thought it was a proportion you were looking at. Copy dot flip. Just do a copy dot flip.
Well, no, it's the negatives there. It's like.
Right, but you're multiplying straight across for multiplying. So the negative would go to the bottom for the,
It'd be -1 and
it'd be -1 times 3, which is -3. And then would be 3 times -5, which would be -15. So you get -3 over -15.
then you'd reduce it
A negative divided by a negative.
is that positive?
So the final answer would be 1/5, 1/5, yeah. Okay. I said last 10 minutes study for your science test. So once again, same drill. Get all your stuff done
Yes.
in student advisement. When you have nothing done, and when I walk in and you're doing absolutely nothing, you're pulling this out and finishing this. If you have other stuff to study for, then you're going to study for your other stuff first, and then this. Everybody, including Sleepy Girl there, is going to is going to study science in silence so that we can actually do some study. So pull your science stuff out, whatever it is, study. Go.
Okay.
So you won't get my notebook.
Once Nick comes back.
She can book it.
Yeah, you got to simplify first. What's a negative divided by negative? Negative divided by negative. Yeah, but fraction bar is a negative, right? Or is a division. You are, but what's a negative divided by a negative? So 1/5 is the final answer. And then you have two negatives. You are third in line. Go sharpen your pencil. All right, we're doing this in silence. Listen. You're fourth in line. What?
Oh, you wrote N when it's K and you didn't
Oh.
write K equals 3 seconds.
each other?
I'm 3 halves.
How dare you?
And you
I'm
didn't
gonna
do
erase all my
the,
mistakes.
and you didn't do the variable equals that.
Well done.
Mr. Charity,
Yes.
I got a math mistake.
One more time. Close towards the end of the day. Yeah,
What?
you're sixth in line.
Can I get some water?
No.
20th.
Hey, let's get some science stuff done.
If I can quiz each other?
You guys, no, let's do it in silence.
That's what I'm gonna do for now, Mr.
No,
It, because most of you people will not, as soon as you hear someone else talking, unfortunately, you have a bad habit of ending studying and turning to talking. So get your science stuff out, study, or finish this worksheet. Those are your two options. We're not gonna do any of that. Vea, you have a great day and we'll see you tomorrow.
Bye.
Anybody else live? Nope.